Hi, everyone. So yeah, I'm Ed Dean. I'm from KETL. We're based in Bristol, in England, a city that's kind of famous for a bridge, I suppose. It's actually a really great engineering city. It's got Rolls-Royce, it's got lots of British aerospace. It's quite close to Wales, but I'll not hold that against it. But yeah, it's great to be here talking today. Like Sean says, we're the UK training partner for Exasol. Actually, first and foremost, we're a team of data engineers. And so what we try to do is take our experience when it comes to working with Exasol and apply that to the training that we provide. So, obviously you've seen earlier on the fantastic Exa Academy. And there's going to be some really great resource there for you to just get going with Exasol. And when you get to that point where you want to come and talk to us, we'll be there to basically take that and turn it into real scenarios. So, the dreaded word, GDPR. Let's look at how we can use Exasol to basically understand our data. We're going to look at the different approaches to understanding data. We'll look at how Exasol and Lua can then help in that process. We'll use a bit of visualization. I think us techies are kind of bad sometimes when it comes to visualizing actually the stuff that we do. We spend the whole time trying to get our business guys a nice picture in front of them, but we use data so much ourselves. So how can we visualize a little bit of that? And then we'll look at a few of the unexpected benefits that if we get enough time, come out of that. Before I begin, though, is Steve here from yesterday, from the fast food? Oh, maybe he had too big a night last night. I just wanted to take this chance to be able to get him to say buffalo wings one more time with his accent, because I spend so much time in America, and every day someone says to me, "Oh, you've got such a beautiful accent." And I thought, well, this is a perfect chance for Steve to stand up and, I can return the favor. But sadly, he's not here. But let's just imagine he just said buffalo wings. So data discovery and understanding your data. Let's take ourselves to that point where with that initial meeting with a customer, we've had a little chat about what they want to do. We started talking about project scale. And before you know it, someone's turned around to you and said, "How much is it going to cost?" And you sit there going, as the developer, saying, "How much is what going to cost? I don't know anything yet. I haven't even seen your data." So they turn around and go, "Well, it's okay, here's our data." And you think, okay, fine, brilliant, we've got the data. And they say, "Can you just tell us tomorrow then? How much is it going to cost?" And how can we quantify that journey to take them from the data that they currently have that we haven't got a clue about to the place where they want to get to? Now, slightly pretentious this next bit, but what I like to think of at this point is an American, slightly anarchic philosopher and composer called John Cage. He's got a great quote there, but he's most famous for a piece of music he composed called 433. So I'm just going to play a little bit of that. This is the first movement, by the way. There are 3 movements. And they're all entirely silent. Okay? Why did he do that? He wants people to try and begin to understand all the other noises that are going on in the environment when you're listening to a piece of music. So what better way is just to play silence? And actually, when it comes to that lovely, great big piece of data that this client has just put in front of us, that's what I want to know. What kind of noise is going on within that data that's going to take my estimate from 50% of the time to clean it up? I think Carl mentions 80% of the time is spent trying to get the data in the right quality. I've seen 95% of the time spent just getting the data into the right place. So how do we understand that noise? And why do we need to understand that noise? Like I've just said, we need to estimate with accuracy, but we also want to gain trust. How can I have that conversation with this customer if I don't really understand their data yet? How can I connect with the kind of challenges that they have with their data if I haven't seen them myself? So I've got to get in there, I've got to try and understand it. And we want to be a trusted partner of our clients. And this is particularly true with GDPR. They're actually looking to us for guidance. And on top of that, of course, with GDPR, we as a data processor have now got enhanced responsibilities. So, yes, there's been a lot about GDPR. It's been kind of refreshing. There hasn't been that much about it as part of this conference. Thank you, guys. But, it's really important, and it's all about trust. It's all about people trusting us to have their data. So that's good. We need it. And this is kind of where we fit in the picture with regards to GDPR. So, lots of lovely data comes in from all its different directions. And we sit and put it into our staging tables. That's suddenly our responsibility. We're going to work that data, we're going to do some lovely aggregates, we're going to make it really great, and then we're going to send it off to CRMs, downstream systems, other third parties. Everything that's happened from us receiving that data to sending it off, from a GDPR perspective, we've got to be clear, we've got to be clean, we've got to be right on top of that. But actually, these downstream systems are also going to look to us to want to understand what their responsibility is. And so, am I going to do this one? Really crap GDPR joke. Someone comes to me and asks, do you know a specialist in GDPR? I say, yes. And he goes, can you give me their email address? No. I won't try that one again. But let's rewind. How do we understand this noise? How do we really get to that feel for it? And on top of that, how do we prove that we understand it, both to ourselves and to our clients and maybe to a regulator? Well, usual method, top down. We ask the client for their data dictionary, Tell us exactly how your data is defined. I don't know if all your data dictionaries are perfectly maintained and completely cover every element of data. It's great. It's a great place to start. The data trail, a bit like the old paper trail. Your data's pouring in, your data's pouring out. Once you understand how it's flowing, you're beginning to build up that picture. And you're going to talk to everyone. You're going to do your full requirements workshop. And that's great. These things are totally how we have always engaged with our customers, to chat to them and work out what's going wrong. We've learned their organization by talking to them. We've understood their requirements, and we've built the relationship. But it takes a long, long time, and it rarely captures everything. And it involves people, and people mess things up. People get things wrong. And I don't know. I was in a system the other day, and it had a production environment, and there was some test data there from maybe 7 years ago, and presumably someone thought at the time they'd made sure that test data hadn't managed to get into the production environment, or maybe they just thought it hadn't filtered through to the warehouse. But it had, and they'd forgotten, because they're people, and people forget. So what else can we do? And this kind of brings us on to the real point of why we're here and why I'm here. You've got Exasol. You've got Lua. Well, why not use that? Why not loop through every single field you have that you've just been given? Obviously, completely ignore all documentation and talk to nobody for a day or two, and just take that data and just really get into it from the bottom up. So it's Lua, right? So we just query the metadata, just give me all columns, right? Maybe I want to ignore my own data discovery schema. I don't really want to start analyzing hash columns. Bit of a waste of time. So okay, you do a little bit of human there just to filter some things out. But, first up, you just get some volumes. Dead simple. Total number of records, total number of nulls. It'll feel the density of the data. And then you think, well, numbers. Good just to know the basic minimums, maximums, averages. Why not do a bit of pattern distribution as well there? Replace out every number with a 0 and just total them up and persist them somewhere. Because, it just tells you something. You can begin to see data out of range, anything that looks immediately wrong, but also just you begin to understand the scale and the precision very instantly of these fields. And then you got dates. You think, well, actually dates, they're starting to get into the interesting stuff now. I'll still do the minimums, maximums, averages for years, let's say, and I'll do a little bit of fishing. Is it a date of birth, for example? You can kind of work out a date of birth pretty easily, especially if you get its distribution. So let's just count up, entries per year for that column. It's a date field. Why not? And you begin to see a picture like this, and you're thinking, all right, this is good. It looks like we've got a kind of spike around the middle there. If this is a date of birth, which it probably is, we can see we're dealing with someone much younger, or a company that's much younger than I am, sadly. But you've also got some weird going on at the start. Why have you got 120 that, in effect, have just been born? Have they got babies? Are we talking, have they got infants stored with their data in this field? So immediately, we've got something to talk about, right? So what you're really doing is trying to complement that top-down approach to say, I'm going to talk to this guy tomorrow because there's something happening here. I need to understand this field. And then you think, well, let's get into the text. And where do you stop? There's all sorts of fun you can have with it. But let's just start with the basics. We'll just get the lengths. Maybe they're all numeric. Some lovely little bit of is numeric function in Exasol, rockets through the whole lot. Immediately you can see, is that column, are they all numbers? But maybe it's personal data. We're talking GDPR. So regexes, right? Just, you're in there, you're looking at the data already, analyzing that column. Well, does it match any of the sort of regexes for emails, addresses, names, that kind of thing? So you can see what we're just basically just building up that picture. And everyone can tell what regex that is, right? Does anyone know? Email. But it doesn't need to be that complex at all. Obviously you can fish out an email field pretty quickly. And that's what you're trying to do. You're just trying to get that really quick insight into the data. But like I say, you're there. You've got the data in front of you. Can you start looking into the sensitivity of that data? I'm from Northern Ireland. And I've been in a call center environment once where, someone was having a heated discussion with a customer. And I could overhear that it was involving the ethnicity. In effect, someone questioning whether they were being treated differently because they were either Protestant or Catholic. And the agent's still capturing this information. It's a free format field, and he's logging the call. So he's just writing down there going, accuse me of being it's a derogatory term, but let's just say Protestant or Catholic. And he stored it in there. And the next time someone loads that account, they've immediately seen that this person is either Protestant or Catholic. So why not just have a little bit of lookup data that's sat beside your process, and just do a little bit of fishing for those keywords. It's different for every organization, but you don't need to get too complex with this before you've actually given yourself something quite useful. And then let's do that pattern distribution again on the text. So I'm going to replace out on every field Every alpha, I'll just replace it out with an A. Every numeric, back with a 0. I just want to see the pattern, right, of that data. And so you group up the whole table. You then see how many of the entries in that column have that pattern. And immediately you can see things like, OK, we've got names here. I mean, it's just a normal, this is a normal standard Gaussian distribution, really reflecting the length, if nothing else. But it's quite clear that that's either a name, a city, that kind of data. It's relatively clean. Something like an email, you end up seeing something that's, again, all right, slightly Gaussian, but at the same time, you've got a lot of other noise in there because it's emails, right? So a lot more differentiation between every value. But once you see that pattern, you know you're dealing with an email, right? So you're suddenly just, I'm using Looker in this example here, and it's just dead quick to have Looker pointing at my schema and just showing me, for every field, a quick visualization of its pattern. And then I get my phones, and I think, this is good. I've got a nice spike. They've obviously done some good work on their phone numbers. They've cleaned them up pretty well. This is a marketing campaign, and they're going to do some outbound calls. I'm all right with this. But at the same time, still quite a lot of other noise in there. It's clearly not a perfect field. So I want to drill in a little bit more. And you can see, yeah, at the top, you've got some pretty good data. Most of the phone numbers are just the standard format. But at the same time, you can also see there's quite a lot of entries that are going to need a bit of work at some point in time. And it's just knowing all those little bits, because it's the little bits that we just spend our whole time on. Those little extra little bits of nonsense of data that's crept in. And if you don't factor for it, you're going to trip up at some point in time. And one thing I quite like, or at least I learned as part of this exercise, this last entry for a phone number, I don't know what the German word is, but in English they call it a Grolix. So if you want to swear, you know, put a profanities, but just using symbols, the word in English is a Grolix. And if someone turns around and tells me that, I actually wouldn't be surprised. I bet you there is a word in German for this that everybody knows. No, okay. I'm going to look it up after. But anyway, that's your English word for the day, Grolix. But you're going to have to deal with those Grolixes. But the lovely thing that's happened while you're doing this is that you basically just rocketed through the entire schema, all that data they've given you. So the example I played with, had about 4,000 columns, terabyte of data, actually a bit more than that. It's terabytes that was compressed, and yeah, 6 nodes. So I had a little bit of beef behind me, but I did it in an hour. So 1 hour. That client's given me that data, and in 1 hour, I'm sat there with this picture in front of me that goes, okay, right? I think actually I probably can begin to think about giving you an estimate that's got an element of certainty, or at least this much tighter range. And I've done it in an hour. And yes, there are tools out there that do great data quality work. Talon, DQ, fine. But Exasol's there in front of you. Lua, it's free. And what I really like about this is that, well, you know, you can just totally tailor it for yourself. So look at the pros at the bottom up. We've said it's fast, it's comprehensive, it's repeatable. So the next day they then say, actually I forgot something. You just run it again. Maybe you run it again just on this new bit of data. But then you find yourself running it quite a lot. And then suddenly it's 6 months later, and you find you're still running it, because actually it's giving you a picture of your entire schema every night. Why not run it? You're not paying for CPU. You just keep chugging away. And so you chuck some alerts on that look at the range of the data. You think, actually, I don't need to hard code that range. I can kind of learn the range. So I'm going to put an alert on, again, I use Looker, but it could be anything that says if I start getting some data in that falls out of range, out of my common pattern, just drop us a mail. Give me an alert. Tell me that something's happened in my data. Because, well, I'm just rerunning this process every night. It's just firing through. And actually, that is how this came around as a process for us to use. We were working in quite an unstable environment. And it was so much changing and so much data was pouring in, we just needed to know every day exactly what's changed at a field level across the entire schema. And I know I can go in there and query it and work it out and that kind of thing, but why bother? This just scanned through the whole lot and then just told me, right? Let's chuck it in Excel, compare it to yesterday's. That's changed. Why? So there you go. You've lost a bit of time, but not much. And of course, you need all the data available. But as an approach to understanding the data, bottom up is a really great way of complementing the top-down process that people typically follow. We've kind of just mentioned all this, and hopefully, if we've got enough time, one unexpected benefit. Sorry, I like Calvin and Hobbes. I just love the phrase, there's treasure everywhere. It's great. We did this, and then we realized with GDPR, there's obviously other benefits. So what about a subject access request? I'll go back to another call center. It was a water company. They probably spent about half a day for each subject access request, i.e. somebody calling in and saying, I want to know all my data about you, that you hold about me. Here's my email, here's my name. And one person would walk around the entire company asking people if they could just do an export from whatever system it is for that particular person. And it's crazy, right? Half a day. With GDPR, companies are recommended to be able to cope with 1% of their customers performing a subject access request at a point in time. 500 days if you had 100,000 customers and they all called in. Let's say you do something stupid and they all get very angry. They can all call in for free. There's not even a charge anymore. It used to be £10. So, well, let's say you've got all your data in Exasol. You're already scanning everything as part of this process. Well, why not scan it for this person, right? And before you actually start scanning everything, let's get those patterns out first as well. And don't go scanning columns that don't have that pattern, right? So don't scan every single field that you know is an email. Scan every single field that has data that matches the pattern of the data that you've been supplied. So it's kind of like an index, it's a bit of metadata that sits above the environment itself. And yeah, run the same process. That same environment with 4,000 columns that we talked about before. We could get that going in about 5 minutes. And every single time you just stumbled across data that matched that of the person who's performing the request, you just flag it. You just know that's one to extract, and at the end, you just pull it all out. Now, whether that's enough as a full response for a subject access request, I'm not sure. It's to be proven. I haven't really put this into a production state yet, but it's going to tell you pretty quickly where you need to go in order to get data about that person, or if you have anything about them. That's all. So there you go. We're KETL. We do training. We love Exasol. We love data. We're over in the UK. If any of you guys want to just come over and see us, we'd love to see you all. It's been great meeting you. And yeah, thanks for your time.